So in this video, we're going to look at another classic mixture problem, this time where we're mixing acids of different percent strengths to come up with an acid mixture that has the strength that we wish. So here it says how many gallons of 5% acid solution must be mixed with 5 gallons of a 10% solution to obtain a 7% solution. So again, we're working with 3 different solutions here. So in terms of making a table, I'm going to say, hey, I have solution 1 that I'm working with. I have solution 2 that I'm working with, and I have solution 3 that I'm working with. And then I need to think about the types of information I'm being given about those solutions, and I see that I'm given a solution strength. That's the percent of the solution that is acid. So I have a strength measurement. And then I have a gallon measurement. And this is a gallons of solution. And the idea is if I know the strength of the solution and the gallons of solution, I can come up with the gallons of pure acid. Gallons of pure acid. Boy, not spelling well tonight. Acid. There we go. So these are the pieces of information that we're going to be able to extract from our paragraph. And this gallons of pure acid, here's the idea. Let's say you have a 5% acid solution. What we need to think about is what does 5% mean? And 5%, remember the percent symbol means out of 100. So this is really 5/100. So this is telling us that there are 5, for every 100 gallons solution, it's telling us that we have 5 gallons of pure acid. Or 100 minus 5 is 95. There's probably 95 gallons of pure distilled water involved. So when we're given the strength of a solution, we can use it to calculate the gallons of pure acid, or whatever. It doesn't have to be acid. This could be a salt mixture. It could be any number of things where you're mixing one type of fluid with another. The percentage tells you the percent of the gallons that belong to the thing that you're interested in. So solution 1, what we're told is it's a 5% acid solution. So in terms of strength, we're going to need to use this number one of 2 ways. We either need to use it as a decimal, because we're going to do math with it. We either need to think of 5% as being 0.05 converted to a decimal, or we need to think of it in its fraction form, which is 5/100. We need to think of it one of these 2 ways. The second solution is a 10% solution, but we're going to be doing math with it, so it's either going to be converted into its decimal form 0.1 by moving the decimal place twice, or we think of it as being 10/100. And solution 3 is a 7% solution, so it's either going to be 0.07 or 7/100, depending on the approach that we want to take. And then we have gallons of solutions. How many gallons of 5%? So the 5% solution is unknown. We'll represent it with a G. And we're going to mix it with 5 gallons of this 10% solution. The 10% solution, there are 5 gallons. So the mixture of the 2 is going to be G gallons of 5% plus 5 gallons of 10% to get the number of gallons of 7%. Now to get the gallons of pure acid, what I do is I multiply the strength times the number of gallons that I have. So if it's a 5% strength, then I either multiply 0.0 5 times the number of gallons at the 5% mark, or I'm going to multiply 5/100ths times G. So I either need to take a decimal or fraction approach to this, one of the two. It's my choice, but I need to take one of these two approaches. So to get the number of gallons of pure acid, if it's a 10% solution, I can either take the 0.1, I can take the percent converted to a decimal, and I can multiply that times 5, or I take the 10/100ths, and I multiply that by 5. 7% solution, I take either the decimal number, 0.07 times the G plus 5, or I need to take the 7/100ths times the G plus 5. So if I'm doing it from a decimal perspective, first, here I have gallons of pure acid. I have gallons of pure acid coming from the 5% solution, plus the gallons of acid coming from the 10% solution need to add up to the gallons of acid for the 7% solution. So I get my linear equation. I get 0.05 G. That's my gallons of pure acid from the 5% plus 0.1 times 5 is going to be 0.6. So I get 0.6. 0.1 times 5 is 0.5, and that's going to equal 0.07 times G plus 5. So here's an equation that says total gallons of pure acid from the 5% plus total gallons of pure acid from the 10% have to add up to the total gallons of pure acid in the mixture of those two things. And I could also have taken the fraction approach. I could have said 5/100ths times G plus 10/100ths times the 5 has to add up to the 7/100ths times the G plus 5. And kind of the nice thing about the fraction approach is this ties back to an earlier homework where we said one way to deal with the problem is to multiply by the least common multiple to clear the denominators. But in this case, the least common multiple is the same everywhere. It's 100. So if we just multiply through by 100, we'll get 100 divided by 100 is 1. We'll get 7 times G plus 5. And we distribute the 100 in here. We'll cancel this 100 in the denominator and leave us with 5G, plus distribute the 100 in here. It will cancel with the 100 in the denominator because 100 divided by 100 is 1. And we'll get 10 times 5 is 50. So fraction approach, it's really clear that multiplying by 100 on both sides is really an efficient approach. It turns out that that's probably the best thing to do here as well, because if we multiply the decimal approach by 100 on both sides, which is perhaps a little less obvious that we should do that, this 100 times 0.07 is going to give us a 7 because it moves the decimal place twice, and it'll be G plus 5, and you'll see it matches exactly what we have here. 100 times 0.05 will move this decimal place twice and give us a 5G, plus when I distribute the 100 times the 0.5 will move this decimal 2 places, which will give me a 50. So I wind up with the same thing either way. But I think it was maybe a little bit more obvious when we had it in a fractional form to begin with. I think a common student approach when they see this setup, I just got rid of my bars, is actually going to be to just leave it in decimal form and grind it out. So you'll get 0.05 G plus 0.5 equals, now distribute the 0.07 plus 0.07 times 5 is going to be 0.35, and then maybe subtract 0.35 from both sides. So we'll get 0.5 minus the 0.35 and subtract 0.05 G from both sides. So 0.07g minus 0.05g, and 0.07 minus 0.05 is going to give us 0.02g, and this is going to give us what, 0.15, and then what your gut going to want to do here, it's probably going to want to divide by 0.02 on both sides, and you're going to look at this mess and you're going to grab a calculator, whereas over here I don't have any decimals and I've already cleared the fractions. So here if I distribute, I get 7g plus 35 on the right hand side. Subtract 5g from both sides, so I'll get 0 g's on this side, and 7g minus 5g is 2 g's on the right. Subtract 35 from both sides, and what do we get? 15. And notice how it's looking the same as it looks right here, except the decimal place is over 2 places, which makes things probably for the human mind a little easier to think about. Divide both sides by 2, and the number of gallons, 2 goes in there 7 1/2 times. So we need 7 1/2 gallons of what? The 5% solution was the unknown. And here, you know, we could look at this. I mean, if you didn't want to deal with this nasty division, you could do what we did earlier and said, hey, what does 0.02 mean? Well, this is 200ths. And then you could replace this with 2 over 100. And then to get the 1 on the g, you could multiply by the reciprocal, 100 over 2. Do the same thing to both sides, so multiply by 100 over 2. This 100 is going to move this decimal place. Let's see, 100 over 2 times 2 over 100 is going to be 1. When you multiply it by reciprocals, you get 1, so you get 1g. The 100 moves the decimal place twice, but it's still going to be over 2, and now you've got the 15 over 2 that you have right there. I think this one, the fraction approach, probably a little bit easier. Again, in the homework, I wouldn't do it both ways. I would pick a way, but I wanted you to see it work through from both directions.